Hello students, this is Pallav sir and I welcome you all to my class. So in today's session we'll have a very basic knowledge on chapter 1 number system. Now we have learned about various types of numbers in our earlier classes, isn't it? So let us first review them, okay? And then we'll learn more about numbers. So as you see on the screen, number one, natural number. It is represented by capital N. Now, what is a natural number? I know all of you knows it. Now, what is a natural number? Counting numbers are called natural numbers. So, example 1, 2, 3, 4, and so on. Isn't it? It's very easy. So, the least natural number is what? 1. And there are infinitely many natural numbers, so we don't know which is the last natural number, students. Okay, now let's step on to the number 2. Number 2 is whole number. Now whole number is represented by capital W. Now what is whole numbers? All natural numbers together with 0. Now you see, all natural number together with 0 forms the collection of whole number. Okay, so in this case, what is the least whole number? The least whole number is 0. And there are infinitely many whole numbers as well. Fine. So every natural number, we can say this as a whole number. Exactly. And all whole numbers are not natural number. Now you have to hear this particular sentence very properly, students. Now all whole numbers are not natural numbers. Why? As 0 is a whole number, which is not a natural number. I am repeating this sentence again. Please listen this very carefully. All whole numbers are not natural numbers. Why? As because 0 is a whole number, which is not a natural number. Okay, so these are some of the very important points. I will give you all the notes. Now let's concentrate on number 3. Now what is number 3? Integers. I know all of you knows this. So let us study about integers. All natural numbers. So what is an integer? Integer is a collection of natural number, 0, and all negatives natural numbers. So as you see in the example part also I have written, it is natural number, 0, and all negative natural number, and this forms the collection of all integers. Okay, and it is represented by capital Z. Now why Z? Now this is a German word. Fine, a zillion meaning to count. Fine. Why integers? See, whole number, so it's okay, it's represented by W. So natural number is represented by N. So why integers? Because it was invented by one very known German mathematician. That is the reason he gave this name as zillion. That is this one. Okay, zillion. And the meaning of zillion is to count. Okay, so what is so 0 is, now you have to understand. See, I've written, so these are all the positive natural number, these are all the negative natural number. And what is 0? 0 is neither negative nor positive. Some of the students remain very confused with this word, that what sign is with 0. No, you have to understand this, students, that 0 is neither negative nor positive. Okay, so I hope this all 3 numbers you have understood. Now let's step on to the 4th number. Now rational number, you have come across this number also, isn't it? What is a rational number? Very important, student. Now see, the number of the form P by Q, where P and Q are integers. Now it's a very important line, students. The number of the form P by Q, where P and Q are integers and Q should not be equals to 0 are known as rational number. Now you will many of the students will ask me, sir, p by q, it is just looking like a fraction, sir. It is just looking like a fraction. Absolutely right. It is looking like a fraction. But why we are calling this fraction as a rational number? So what is the difference between rational number and fraction? Now students, if you just go back and just recollect your memory, you will never see that a fraction was supposed to be in the negative form, isn't it? Fraction is always positive. Any fraction is always positive. But here you see why I said that why this line is so important, as because p and q, see, p and q are integers, so p and q both can be negative. So negative fraction is called, negative fraction is also called, not called, is also called rational number. That is, 2 by 3 is also a rational number. Minus 2 by 3 is also rational number. Understood? That is, again I am saying 2 by 3, that is 2 by 3 is also rational number, and minus 2 by 3 is also rational number. Okay, so here now you have to understand the difference between fraction and rational number. Okay, now it is represented by q. Now this is a short way of remembering what is a rational number. So what is a rational number? It should be in the form of p by q. P and q are integers and q should not be equals to 0. Now some students will ask me, so why q should not be equals to 0? Now suppose if I write, just a minute. Now suppose if I write 2 by 0, students. Now 2 by 0, we don't know the answer. Why? If we divide 2 by 0, no, 2, does anyone knows that 0 into what is 2? We don't know, isn't it? We don't know this answer. Fine, so it is undefined. So no mathematician on the earth has able to answer this. So since it is still we are getting on with the answer, so we say this form as undefined. Okay, so now let's move on to the next topic. So our next topic is the simplest form of a rational number. Now what is the simplest form? This also we have done in our previous class. So let me just give you the definition of the simplest form of a rational number. A rational number p by q is said to be in its simplest form when if p and q are integers having no common factor other than 1. Now what I'm trying to say is, see, these two example, 1 by 2 and 3 by 4, these are already in the simplest form. Why? As because 1 and 2, they are having 1 as a common factor. So what is the meaning of common factor? Sir, I forgot what is a common factor. Please explain what is a common factor. So common factor is, students, suppose 1 is divisible by 1 only, isn't it? And 2 is divisible by what? 2 into 1, isn't it? So 1 into 1 is 1, 2 into 1 is 1. So what is a common factor? You see, yes, this is the common factor. So CF is what? 1. So this is common factor, students. So these two numbers are having common factor. No common factor other than 1. Now let's check about this one. So let's check 3 and 4. Okay, now let's check 3 and 4. So 3 is what? 3 into 1. And what is 4? 2 into 2 into 1, isn't it? If you prime factorize 4, what will happen? This is what we are doing, prime factorization, isn't it? So when we write all those factors here, do we see any other factor common other than 1? No, we don't see, isn't it? So 1 is the only common factor here. So that is the reason the common factor of 3 and 4 is 1. And that is the reason we are saying this as this form as a simplest form of a rational number. But now you see 6 upon 9. 6 upon 9 is not in the simplest form. Why? Because it can be reduced, isn't it? So with what you can reduce? With 3. Because these two numbers can be divisible by 3, isn't it? So if you reduce it, 3 2s are 3 3s are. Here you see I've written the answer. Now you have converted 6 by 9 in the form of a simplest form as 2 upon 3. I hope you have understood what is the simplest form of a rational number. Now students, let's step on to the next topic. Yes, now this is also very important topic. That is how to represent rational number on real line, or you can say number line. Fine. Now let me give you, now as we have come across, as we have now we know that what is a rational number. So we can say that, just a minute. Now we can say suppose 2 is also a rational number, minus 2 is also a rational number. Now some of the students might be thinking, so why 2 is a rational number? You said p by q, rational number should be in the form of p by q, so how 2 is a rational number? Fine, it is not in the form of p by q, but there is one invisible number. There is one invisible number. What is it? 1. We don't write 2 by 1. We write 2 by 1? No, we don't write 2 by 1. We just write 2. But that doesn't mean that 1 is not there. 1 is there. Fine. So this is how we can say that this is in form of p upon q, where q is not equals to 0. Fine. Q is not equals to 0. So we can say that 2 minus 2, even 0 also, students. Even 0 also is also a rational number. Why? Because 0 also can be written as 0 by 1, where you can say q should not be equal to 0. They have not said that p should not be equal to 0. They have just given us a condition that q should not be equal to 0. Understood? So 0 can be also considered as a rational number. So now I'm just giving you some of the examples of a rational number, then I will show you how to represent this. Now if 2 is given, we know that we have done this in our junior classes. Minus 2 also very easily can be represented on the number line. Now what if I give you 2 upon 3? Now what if I give you 5 upon 7? Fine. How to look at this? Now this is what you have to learn in this class. Fine. So suppose for this you need to draw one line. Sorry, not draw one straight line. Just pardon me. Okay. Now we'll calibrate it. That is 1, 2, 3, 4, 5, 6, 7, 8. Now first of all, as you see, these are positive rational number, isn't it? That means it should be on the right hand side of the 0. Am I clear? It should be on the right hand side of the 0. That is, suppose if I consider this as 0, so 2 by 3 should be on the right hand side of the number line, isn't it? Now for this type of rational number, you have to be very careful with the denominators. Fine. So what is the denominator? 3. So the first number would be 1 by 3. The second number would be, second line would be 2 by 3, and the third line would be 3 by 3, then 4 by 3. Understood? Very easy. 5 by 3, then this would be 6 by 3, this would be 7 by 3, and so on. So you will write like this. Okay. Now which rational number you have to look at? 2 by 3. Now where is 2 by 3? Here is 2 by 3. So you will circle it like this. So this is how you will represent this type of form in the number line. Fine. Now let's see how to locate 5 by 7. So how to represent 5 by 7? So we'll again draw another line like this. Mark it. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12. Now again 5 by 7 is a positive rational number, so it would be on the right hand side of the 0. So you will write 0 here. Okay. So the first number, what is the denominator? 7. Now we will write 1 by 7, 2 by 7, 3 by 7. So this denominator will remain constant. What we are changing? The numerator, students. First 0 by 7, you can write 0 by 7 also if you want. No issue. 0 by 7, 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7, 8 by 7, 9 by 7, and so on you can write. Fine. So which rational number you have to locate? Which number? Sorry, I've chosen the wrong color. 5 by 7. So where is 5 by 7? Here it is. 5 by 7. So this is how you will locate, or you can represent the rational number on the real line. Okay, I hope you have understood this. Now let's move on to the last topic of today's session, that is finding rational number between two given rational number. So this is also very interesting topic, student. Now let's see. I'm going to explain this topic with the help of two examples. Fine. First example is how to find out the rational number in between 2 and 3. Okay, very easy, very easy. Only one. Okay, finding rational number, that is how many rational numbers we have to find. Only one. Let's start with one only today. Okay, so in next class I will teach you how to find more than one rational number in between two given rational number. Okay, so in today's class we will only know how to find out only one rational number between two given rational number. So suppose these two rational numbers, you have to first of all find out only one rational number between these two rational number. So what you have to do is that the required rational number equals to 2. You have to add this 2 number and divide it by 2. That's it. It's as simple as this. So now just 2 plus 3 is what? 5. 5 by 2. And if you want, you can divide it also. That answer will come as 2.5. So you can write like this. 2.5. So 3. So 2.5. 2.5 is the rational number. Fine. No. We cannot give it in the... Sorry. So how to write it down? Rational number. So 5 by 2. How to write it down? 2. Then you write 5 by 2 and 3. So this is the required rational number between two given rational number. Okay. This is how you will find out rational number when two rational numbers are given to you. So this is one type of example. Now let's move on to the second type of example. What if students, if it is given like this, suppose 2 by 5 and 3 by 5. Fine. 3 by 5, 2 by 5 and 3 by 5. So we need to find out how many rational number? Only one. So again you will write required rational number. Same thing you have to do with this also. That is 2 by 5 plus you have to add the required rational number given, and the sum you need to divide it by 2. So first of all we'll solve the bracket. That is 5 LCM is 5. It will be 2 plus 3 divided by 2. So 5 upon 5 divided by 2, that is 1 by 2. So what is the required number? How to represent your answer? 2 by 5, then we'll write 1 by 2, and then we'll write 3 by 5. Okay, so this is the required rational number. Okay, I hope you have understood. So what we are doing is here that when only one rational number you have to insert between the two given rational number, what we are doing? We are just adding the two given rational number and this with the sum, and we are dividing the sum by 2. So that would be the required rational number. Okay, and this is how you have to represent your answer as well. Fine, I hope you have understood. So let's recollect what we have studied today. So we have started our class with a review, that is what is natural number, whole number, integers, and rational number, isn't it? So go through all those things very, very properly. Then what is the simplest form of rational number? This is also a very important thing. I'm going to share all those notes in the WhatsApp group. Go through it very, very properly. Number 6, how to represent a rational number. So if 2 and minus 2 is given, I hope it is so easy. You have already done in your junior classes. So now what if I give you 2 by 3 and 5 by 7? I've already shown you this is how you will locate 2 by 3. This is how you will locate 5 by 7. Fine. Be careful with the denominator. Now let's see the last topic of today's session. That is how to find out the rational number between two given rational numbers. So I gave you two examples. That is, one is 2 and 3. Very, very easy. The concept will go for both the example. The concept is what? If the two given rational number is given, first you have to add those two rational number, and the sum that you will get, you have to divide that sum by 2. Fine. And that would be the required rational number. But when you are placing your answer, you should place your answer like this and give a box so that the teachers can understand. So this is the required rational number that is in between these two given rational number. Okay, let's go. Now what if 2 by 5, if the rational numbers is in the fractional form like this? Fine. Now it is also in the fractional form, but it is one is not showing here. But if in the question paper, if you get 2 by 5, 3 by 5, how to find out the required rational number? The concept is absolutely same, student. That is, you have to add this 2, and the sum that you will get, you have to divide the sum by 2, and in that way you will get the required rational number. Okay, I hope all of you have understood and enjoyed this classroom. So till we meet again, God bless you all. Take care and stay safe. Thank you so much.